Okay, I want to start today's video by showing you some things on the calculator. Under the null, we talk about the settings we need for our calculator. It's very important that we have these settings proper. So I just want to run through with you on the Inspire. If you go to your home screen, you go to settings, and this isn't a bad idea to check this from now on. We've ignored it so far this year, but now that we're working in Trig, it's going to become more important. So we'll go home and we'll go to settings, and we're always interested here in document settings. There are two things we need to worry about. And the two things we need to worry about are the display digits. We always want it to say float. There float lots of numbers, but the only thing we want is just a float all by itself. And then we want our angle to be in degree. If we don't do this, our trig buttons don't work the way we expect them to, and we'll get wrong answers and probably not recognize that fact. So if it says float, it says degree, come on down and click on make default. Say OK, and now for the rest of your class period, for the rest of your test, you'll be sure that you're working with the proper settings in that calculator. I'll just go to a new document and bring up a calculator page for should we need it a little bit later. Okay, moving on to what we need to do in this for this lesson. That out of the way. What we need to do first of all is find the exact value given radian measure. Okay, well, since we already know everything in degree measure, why should we relearn everything in radian measure? Why don't we just convert to degrees, and after we convert it to degrees, we'll take it from there. So I'm going to begin by converting pi over 4 to its degree measure, and I do that by removing pi and putting a 180 in its place. When I divide 180 by 4, I get 45. Now I'm looking at the sine of 45 degrees. As a matter of fact, that's just a number you'll look up in your table. Sine of 45 degrees is square root of 2 over 2. So that is the exact value for an angle that's measured in pi over 4 radians. That is your answer. Since we're already in quadrant 1, we don't need to bother with reference angles. We know everything in quadrant 1 is positive. Let's do one more example of finding exact value. The secant of 4 pi over 3. Now this one will be a little bit more involved. I'm going to begin by converting to degrees and taking a look at what I've got. It's still secant. I'm going to replace the pi with the 180. I'm going to do 4 times 180 on top, 3 on the bottom. I'm doing this in my head. I believe I'm getting 240 degrees. So now I don't have a quadrant 1 angle. I'm going to have to make my sketch and plot that 240 degree angle down here. This is 180. This is 240. Here's my angle theta, or any other variable of your choosing. The difference between 180 and 240 is 60 degrees. So my reference angle here, I'm in quadrant 3. My reference angle is going to be 60 degrees, and I have to figure out the sine. Don't forget, there's a very important piece of this when you do that. It's a big deal. Not including a negative when you need a negative is not just a 1-point error. It's actually a 2-point error. It's a much more important thing. So secant of 240 becomes secant of 60 degrees, and I have to ask myself, should that be positive or should it be negative? Well, we're going to have to get into our reciprocal functions here. You think about the hexagon. Secant is the reciprocal of cosine. Cosine in quadrant 3 is a negative number, so we're going to turn this into a negative secant of 60 degrees. But again, we're using reciprocal functions. I didn't memorize secant of 60 degrees, but I did memorize cosine of 60 degrees. Cosine of 60 degrees is equal to 1/2. So I'm going to want the reciprocal of the cosine of 60 degrees. I want the reciprocal of 1/2, which turns out to be equal to 2, but it's not a positive 2. I'm going to use that negative sign. So my answer here is -2. And on the left you saw a problem of something that's probably the least involved thing you'll have to do. This is probably the most involved thing you'll have to do, where you'll start off in a quadrant other than quadrant 1, and you'll have to use a reciprocal function. Okay, moving on to the second thing you need to do for today. Find the angle theta in radian measure. I'll give you the exact value, the exact function value. Remember, that's just a number. There are no units. We need to come up with the angle theta, but we need to come up with that angle theta in radian measure. Well, I've given you the exact value, square root of 3 over 2, and you will probably recognize that square root of 3 over 2 cosine comes out of your table. And so you might be thinking that theta is equal to 60 degrees. If you memorize a table, that's what you should be thinking. But let's see if our calculator is of any help with this. If we know the cosine of theta is square root of 3 over 2, I wonder if I could use cosine inverse to tell me what the angle is. Let's give that a try. Trig button, cosine inverse, and let me put in a fraction template there, a square root of 3 on top. And on the bottom we're going to put the 2, and I'll hit the enter key. And what I get there is 30 degrees. Well, I'm glad I checked with the calculator, because when I was thinking about my table lookups, I don't have a table here, cosine for 30 degrees is actually square root of 3 over 2, so I pulled the wrong number out of the table. That should have been a 30 degrees. But what I want to point out by this is that your calculator can help you even though you have an irrational answer. Your calculator can't come up with the square root of 3 over 2, but when your calculator uses its approximation for square root of 3 over 2, it's so close to what square root of 3 actually is that it does come up with the correct angle for you. So if you have that radical already, you can put that radical into your calculator to help you. It's just that you can never have the radical come out of the calculator. You'll never see an answer come out of your calculator that has a radical in it. So we know that angle theta is equal to 30 degrees here, but as you can see by the instructions, we were supposed to find that angle in radian measure. So in radian measure, we're going to have to take that 30 degrees and convert it back. So let's use the formula we memorized the other night. Degrees over radians is equal to 180 over pi. We know the degrees is 30. We don't know what the radians are. That's what we're looking for. It's equal to 180 over pi. We'll do our cross multiply. So 180x is equal to 30 pi. We will divide both sides by 180. And this is going to give me x is equal to pi over 6. So that means that this theta that I was looking for, the angle I was looking for in radian measure, is pi over 6. Now what did we do there? We actually decided to work in degrees first because we know everything about degrees. We've memorized degrees, etc., etc. So we'll just do all our work in degrees, and at the end of the problem we can convert back to radian measure. Okay, well that one was in quadrant 1. It's a number we clearly recognize. Let's see what happens on the other side of the screen when I have a different starting problem. Okay, I've got cotangent of theta is equal to square root of 3. Well, now we've got a reciprocal function. Square root of 3 might be something you recognize from the table. If at the bottom of your table, and I'll write the bottom row out this time, square root of 3 over 3 would be for 30 degrees. Oops, 1 would be for 45 degrees, and square root of 3 would be for 60 degrees. Well, keep in mind that I'm actually working with a reciprocal function here. And with the reciprocal function, then what I have to consider with the reciprocal function is that this square root of 3 is the reciprocal of the tangent function. So I'm looking at the tangent row. I need to find the reciprocal of square root of 3. The reciprocal of square root of 3 is going to be square root of 3 over 3. So I'm talking about a 30-degree angle here. And now let me pick up the calculator and see if I can use that calculator to help me. Well, the problem here is I've got one of those reciprocal functions. But remember how we can deal with reciprocal functions. If I write 1 over cotangent theta is equal to 1 over square root of 3, I can replace 1 over cotangent theta with tangent theta. So it says tangent theta is 1 over square root of 3. And I don't really have to do any work with that if I want to check it with the calculator. Remember, if I have radicals already, I can put them into the calculator. So let me see if the inverse tangent of 1 over square root of 3 works out the way I expect. Let me see if we get a 30 degrees for that. So back to our calculator, and we're going to put in the inverse tangent of 1 on top. And the square root of 3 on the bottom. We'll hit the enter key, and I'm just verifying that I did come up with the correct angle of 30 degrees. So now that I have the correct angle tangent of 30 degrees, or that theta is equal to 30 degrees, now I can take that angle and I can turn it into radian measure. Well, actually that turns out to be the same thing as the last problem we had. 30 under 180. Oops, let me erase that. Degrees over radians. So I'm going to put 30 degrees over r x, whatever variable you'd like, is equal to 180 over pi. And when I solve it, I'm going to end up again with that pi over 6. So I end up the same answer as I did the last problem. Typically, when we give you these types of problems, we're really not going to ask you about coming up with those radicals in other quadrants, because the reference angles are the ones you memorize, and the reference angles are always in quadrant 1. Let's move on to the final part, where we are asked to evaluate trig functions for radian measures. And you saw under the no, when you see any function at all of x, whether it's a trig function or any other function, and you're asked to evaluate that function of x, but you're given some number for x, all that means is we're going to substitute this number wherever we see an x. So I'm going to rewrite this function as the cosine of 2, but I'm not putting an x in here. Instead, I'm going to put that pi over 4 in here. And now my job is to simplify what I see. So I'll say it's equal to the cosine of 2 pi over 4, but that's the same as pi over 2. Now, cosine of pi over 2, let's change the degree mode, or change this to degrees. I'll put a 180 in place of pi. That means I really want to know what the cosine of 90 degrees is. That's one of those quadrantal angles. 90 degrees is up here, and that point on the unit circle is 0, 1. So without my calculator, if I'm looking for the cosine of 90 degrees, I can just look at that coordinate. I know the answer here is 0. You could also pick up your calculator and type cosine of 90 degrees, because your calculator will tell you all the quadrantal angle values. So cosine of 90 degrees is 0, so 0 is my answer. Does it matter whether it's in radians or degrees? No, it doesn't even make sense to ask that question. Remember that the angle is the thing that could be measured in radians or degrees, but this is just a function value. It's just a number, and 0 is 0. We don't assign any particular kind of units to it.